Hello, and welcome to 5 Minute Math. Today we are looking at the Algebra 1 concept of equations for parallel lines. This is standard A.3E in the great state of Texas, and we are using item number 22 of the 2025 released STAAR test. This is a new item type called drag and drop, and if you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we've got two blanks here, and you notice that each answer can be used more than once, and each of these possible answers can be put into either one of these boxes. So they're not limited in any way. And if I were to just move in one and then try to move on, obviously I'd get that warning message. This is a 2-point problem, one for each blank. So let's go ahead and figure this out so we can get both of our points here. So we have in the equation of a line is y equals negative 3/5 x plus x. This is line N. And line P is parallel. All right, and it passes through this point. All right, so let's do a quick sketch. This is not going to be perfect. This is just going to be a rough sketch. Let's do line N, and I'll do that in red. So negative 3/5 x plus 6. All right, so here's my 6, and this is going to be my 0, 6. And I know that's my y-intercept because that's in that B position. And then my slope is negative 3/5, so it's going to go down from left to right. And for every 3 units down, so it's going to go down to about 3, it's going to go over about 5 units. So let's call it right here. And that would be 3. Let's see, our x is going to be 5 and our y is going to be 3. All right, so we're going to do that right there because I went down 3 and I went over 5. And then here we go. I'm going to get a line kind of like this. Now, if I were to look for this new one, it's going to go through point 15, negative 6. So it's going to be way out here, and then it's going to be down here some. So maybe here. I'm not sure whether it's going to go probably above it. So maybe like this. I might have gotten my scale wrong, but I'm thinking it's going to be kind of something like this. But one thing we do know, it's parallel. So if it's parallel, we need to find that slope of this new line, and we need to write it in slope-intercept form. Okay, so we're going to need two different tools here, or our reference materials. So we're going to need our slope-intercept form. So we need to know what that is. So let's get a different color here. We need y equals mx plus b. We're also going to need this point slope form. Y minus y1 equals mx minus x1. We're going to know this because we're going to need this because if we're only given a point and a slope, we're going to need that to figure out what that b is. Now, one thing we need to know is that one of these answers is extremely easy, and it's what is the slope of the new line? Well, the new line is going to be parallel to the other line, which means they have identical slopes. So parallel lines have identical slopes. If the first line is negative 3/5, well, then guess what that next line is going to be? Negative 3/5. No calculation needed. We simply need the calculation to figure out what that b is. All right, so let's use what we know to figure out this new line. So I'm going to say y minus, and what point does it go through? Well, it goes through this 15, negative 6. So that y value is going to be negative 6 equals negative 3/5. That's my slope, x minus that x value 15. So that's going to end up being y plus 6 equals negative 3/5 x minus 15. I'm just going to go ahead and distribute that out, negative 3/5. So the negative 3/5 goes in both spots. So that's going to be y plus 6 equals negative 3/5 x minus 15 times negative 3/5. Well, the two negatives are going to cancel out. That's going to be 9. So that's going to be plus 9. And I need to get rid of that 6. So I'm going to subtract 6 from both sides. So y equals negative 3/5 x plus 3. So then we are going to, so this, I ended up drawing this wrong. That's going to end up going below. I was wondering about that. Right here. And then we've got it right there.